Okay, thank you. Hope it doesn't come in other languages. Take place. We're going to start our panel on eVTOL, and we try to bring you the latest development and especially a focus on Mosaic, because there are VTOLs coming up which are going to be flying maybe in ultralight class in Europe. There are aircraft flying in as certified aircraft, and there will be aircraft, eVTOL aircraft in Mosaic, and we try to bring you some example of each, and also our additional guest, Ji Jin, aus China. They are talking about a control system for different eVTOL systems, which is scalable from drones, small drones, up to eVTOLs. With this said, I don't want to talk too long. Just one thing, remember, right after this panel, at 4:30, we'll have the prize giving of the eFlight Expo Award of this year, and afterwards, a little party. So, stay tuned. And with this, Michael. Michael is first. Michael, please come to the stage, because I was really surprised when I saw their aircraft in UK, and I haven't heard about it, and they already have been flying. So I immediately went there, and they are having at the moment a two-seat aircraft which can fly in the Mosaic class. And I'll leave the word to to Michael Thompson. To Michael, just explain us what you're doing, and later in the panel discussion you also may ask questions.
Good afternoon, everyone. My name is Michael Thompson. I'm the founder and CEO at Skyfly Technologies. I'm going to briefly talk about our aircraft, why we've made it, and then I'm also going to touch on Mosaic in a bit more detail and why it means a lot for us as a business. Let's see if this works. Doesn't work. Do I have to point it somewhere? Sorry. There we go. So, we've built our first prototype. Our aircraft is called the Axe. So it's a two-seat, side-by-side seating LSA, light sport aircraft. So we actually were quite not well known, but we carried out Europe's first airfield-to-airfield flight of an electric vertical takeoff and landing aircraft. We've flown in both the UK and the US now under experimental permits. We conducted probably more than 150 flights now. We've got a sort of growing order book, mainly in the States, obviously, because it's been facilitated by Mosaic, but got 56 customers. They're just private owners and operators. We've set up a facility now in the UK, in Oxfordshire, where we can build about 20 aircraft a year. And then we're also opening an office in Florida as well, where we'll have a bit more space for producing aircraft as well. But as you can see, the aircraft's flying. This is in the UK mainly, I think, this footage here. But there is some footage of us flying in the US as well, which is on YouTube. So what was the reason for us building this aircraft? I'm a helicopter pilot, and I've seen firsthand, firstly, they're very noisy. If you've ever tried to fly an R-22, they're very difficult to fly, extremely expensive to run. So you're talking like £300 an hour to fly an R-22. Mechanically incredibly complex, really. You've got main rotor gearbox, tail rotor gearbox, you've got that piston engine, all these hundreds and hundreds of moving parts. And we thought there would be a better way to fly, which is why we designed the Axe. So it's a fully electric canard wing layout. So it's got elevators on the front wing, which is the canard, and then ailerons on the main wing, and it's got a large fin and rudder. So one of the most unique aspects of our eVTOL is that it's completely mechanically controlled in forward flight. So your control surfaces allow you to do power off glides. So if you lose complete power, this aircraft can still glide and land. That was one of the biggest sort of design characteristics I wanted from this machine. Glideability, obviously electric propulsion. There's 8 separate electric motors on this aircraft. There's 2 per corner, so you've got redundancy in the hover. A fully carbon composite fuselage and wings. Basically everything's carbon fiber, which gives us a maximum takeoff weight of 750 kilograms with a 200 kilo payload. And obviously electric propulsion is fantastic for low maintenance costs, which then work its way down for the owner. So you're looking at roughly £70 an hour versus £300 an hour for a helicopter. So the idea is you're saving money not only in acquisition costs but also running costs. So I won't take too much of this because Scott's here and he might be talking about it a bit later in a bit more depth. But Mosaic is the new rule set that's just been announced at Oshkosh last year in July. So modernisation of special airworthiness certification. And so what Mosaic is, it's a change to or addition of Part 22 to the light sport aircraft rules, and essentially it's opened up the two-seat light aircraft market in the States to not only piston-engined aircraft, but also electric engine aircraft, turbine aircraft. You can have multiple engines. They've added sort of novel flight controls or simplified flight controls as well. So there's a whole host of new features that they've just added to the light sport aircraft certification route. And the key thing that you've got to remember about the LSA route is it's not a type certified aircraft. It's a self-declared compliance process. So there's the ASTM standards which are released. So I think we're nearly there with the ASTM standards. They're going off to the FAA with the first draft. So hopefully by July this year that will all be passed through. But essentially the ASTM standards are released and then you as a manufacturer have to comply to those standards. So unlike a type certified aircraft, it's a much less complex, drawn-out process to certify your aircraft. It is still limited to 2 seats, which I'll come on to in a sec. But generally, the perception of light sport versus a certified aircraft is that they're more dangerous, but that's proven to not be true now. Whilst there are fewer flying, there are less incidents with LSA aircraft. And as you can see, as time goes on, these aircraft are getting safer and safer. And that is partly because the LSA category promotes safety. It allows for new safety equipment to be installed in these light aircraft, which actually promotes safety. And really, I'll briefly touch on this, but the idea of Mosaic is that if you try and ask people to reach a certification level that's far, far too stringent for the aircraft that they're flying. So, for example, at the moment in Europe, if we wanted to go and certify our 2-seat eVTOL, which is only for private ownership and operation, we would have to go through a type certification route, which would just cost a huge amount of money and time. And really, it's far too high a level of certification for something that is operated where our aircraft is operated, day VFR, etc. So the sort of safety continuum that the FAA works to is really pragmatic, and actually what they find is it promotes safety, so too much certification requirement actually increases risk rather than reduces it. So I have to be a bit miserable. We are in Europe right now, but unfortunately I have to say that having spent a week in Florida last week at Sun and Fun, which is probably the second largest air show in the US, the outlook for Europe is not great unless we can replicate or follow the FAA's ASTM standards and do a similar light sport aircraft equivalent, because we are thinking of moving our entire business to the States purely because there's a framework that exists. I think that a lot of other light sport aircraft manufacturers will also be considering the same thing. So I think my final message is that, EASA, CAA, who we are continuing to work with on this, need to really get a move on when trying to compete with the FAA, promoting general aviation, reducing traffic on the roads and getting more light aircraft in the air is ultimately what the FAA have allowed by introducing Mosaic, an aircraft like ours to come to market and be able to sell to customers. So yeah, it's great news all around. But thanks for your time. And any questions, I'm sure you can ask me in person because there's not many people here.
Hello, Michael, and I hope, and I'm sure it's going to fill up over the time here. As Mosaic is the topic where a lot of the presenters, a lot of the manufacturers, especially those on the B halls here, which is the ultralight aircraft, which are looking to this expansion of their scope, not only for eVTOL. That's why I invited Scott to give a presentation because he, as the president of Llama, has been very heavy involved to the design of this modification of the LSA rule. So Scott, if you come up, would be great. Your slides are up already. That's perfect. Green one.
Yep, thank you, Willie. Welcome, E-Flight entrepreneurs, enthusiasts, and invited guests. I'd like to first thank Willie Taki for hosting such an informative event at one of the premier showcases in Europe. We love coming over to Aero. It's a beautiful people and beautiful cultures all through the land here. I'm Scott Severin, the president and chairman of the board of Light Aircraft Manufacturers Association based in the United States. And thanks to you all for participating in this global event today. Today I'll provide a broad, high-level overview of Mosaic. The big opportunity and trend in the regulatory environment is moving from CAA-type certificated compliance to self-declarative compliance through industry consensus standards. Remember, self-declarative is very important, and this is right where Llama resides as an advocacy association. Type certification is cumbersome, it takes a long time, and this freezes advancements, and it freezes finances for those people participating that are manufacturing the great aircraft. Self-declarative compliance is comparatively nimble, much more cost-effective, and adapts to new emerging technologies, just as you saw here a second ago. This is all coming about because of Mosaic. Mosaic stands for the Modernization of Special Airworthiness Certification. First, here's the reasoning behind the whole Mosaic process. An important concept at the FAA is the safety continuum. This is a principle guiding the agency's approach to regulating aviation safety. It moves away from a one-size-fits-all approach in terms of certification, and this flexible framework allows the FAA to balance safety risks and the needs of the aviation industry and the flying public, while also encouraging innovation. And Mosaic is certainly encouraging innovation. Some points on this graphic. Increasing the scope of LSA enhances the tailoring, although more prescriptive philosophy from FAA's Part 23, which is type certification. This makes the safety benefits of LSA much more accessible across the board. Thank you so much. LSA can also be an entry point for innovative technologies that can grow along the spectrum. So, how is light sport aircraft working so far? Let's see. Really pretty well. If you look at the chart on the left, these are accidents per 100,000 hours. Amateur built safety is improving, and LSA safety is equivalent with type certificated aircraft. This information is a little bit updated. Current as of 2023. The chart on the right side is accident counts. Experimental and LSA have fewer accident counts, the blue and the green. than the red, which is general aviation, but that's because there are so many more general aviation aircraft. What's interesting about this, though, as the number of light sport aircraft has increased in production and use in the United States, the safety level, the accidents have remained very low. So that translates into an improving safety record. Let's understand the goals of Mosaic. ASTM industry consensus standards compliance, while much simpler than Part 23 certification, is still thorough. Let's just start at this first number right up here at CAR 3. CAR 3 gets into, no, don't worry, we're not going to go through all of these things. We're not going to discuss all of these, but the point is that there's a lot involved to make sure that new technology solves more problems than it creates. Success occurs when the problem you solve is smaller than the problems created from the problem you solve is less than what you were working on. What Mosaic does is to make sure the process is simpler while maintaining safety. And all of this while reducing costs. The way to reduce costs is to keep things simple. The way to keep things simple is to keep the regulatory burden down and to keep the compliance requirements down. As an industry advocate, what LAMA does is work hard in the ASTM meetings to keep things simple. Respectfully, we've got a lot of terrific engineers in the ASTM meetings, and what do engineers do? Well, they engineer. As well, on the regulatory side, we've got the FAA and regulators in the room, and what do regulators do? They regulate. Well, what does LAMA do? LAMA says, wait just a second, let's keep things simple. One of the reasons that light sport aircraft has been so successful and so safe, as documented by the FAA in those slides, was because we've got a regulatory and compliance frameworks that work very well. They work well for the manufacturers, they work well for the public, and clearly they work for the FAA. So as we create new regulation, let's not break what makes it work. There's a new regulation, Part 22, that's coming in with Mosaic. It's just one number under Part 23. It's very important that we do not recreate Part 23. Otherwise, we'll have Part 23, which is type certificated aircraft. We just need to be careful that we don't damage that which keeps this so special. And that's one of LAMA's primary objectives right now. So to do that, LAMA works together with associations and governments that affect change. Specifically, LAMA board members are voting members on the ASTM committees that create the standards for light sport aircraft and beyond. And LAMA is on the executive committee for ASTM F-37 light sport. Here's a high-level look at what Mosaic brings: a dramatic expansion of the LSA category, the addition of a new FAR Part 22 for LSAs, no explicit weight limit, which is terrific, a 61 knot landing speed for light sport aircraft, a 59 knot clean stall speed limit for sport pilots. So that's different from the light sport aircraft. You're talking about the aircraft versus the airman and what privileges the airman has. A 250 knot maximum speed. 2 seats are allowed for all light sport aircraft except airplane, which allows 4 seats and 2 occupants for the sport pilot. Multi-engine is allowed as a light sport aircraft. Electric propulsion is allowed. Turbine propulsion is allowed. Powered lift is allowed. Variable pitch propellers now can be used in light sport aircraft. Retractable gear is allowed. Rotorcraft are allowed. And factory-built light sport, factory-built gyroplanes are allowed. IFR flight is allowed. Night flight can be allowed for sport pilot that has basic med and an endorsement. And I just want to make sure I'm clear on this. The difference between the sport pilot airman is separated out in the regulation from light sport aircraft. Just because you're a sport pilot doesn't mean you can fly any light sport aircraft anymore. The light sport aircraft now are becoming much more capable because of Mosaic. As multiple aircraft types are considered in light sport aircraft, various factors might be applicable. These are things like higher inertial load factors for impact, submarining. This is where the pilot on impact could slide down out at the bottom of his seat. This is a safety issue that can be addressed with a 5-point harness or with seat structure that supports the body so it isn't inclined to fall down into the floorboard. Clear zone in front of the occupants is a clear safety issue that's being addressed. Chamfer on the lower end of the firewall or skid plate to keep the aircraft from going down and submarining into the ground. Turnover testing is looked at. Egress testing is modeled and documented. Forward fuselage upward impact load tests are performed. And there are other items for Part 22 compliance. That's the new regulation for light sport aircraft. So while there is quite a bit more complexity and capability in the aircraft, this all has to be documented so that we maintain an appropriate level of safety. Other items of note are additional electrical requirements, flutter requirements, dive testing, ground vibration testing, audio warnings. Angle of attack is coming in to be a standard requirement. Aerobatics, indirect flight controls, different from simplified flight controls, which are coming up in the light sport world, which will create an even easier, more simple method for flying. Software and firmware need to be documented and tested. There's noise regulations that presently will be in the United States voluntary. Europe is quite a bit more sensitive to this and have compulsory noise requirements, but in the Part 22, presently it looks like it will be voluntary. Propulsion types, I think we've discussed a little bit. We get turbine, electric, twin engine. Just a lot of new types of aircraft. There's a process that has to occur, however, for Mosaic to complete. Typical processing time for the FAA can be several months to over a year or greater to accept standards. The FAA wants to fast-track this process, however. There is plenty of public pressure and political pressure to move this forward. In planning meetings with the FAA, we're expecting about 3 months, maybe a little bit less. The consensus, the industry consensus standards have to go through all the stakeholders, all the departments of the FAA, legal, medical, airworthiness, flight standards, and they all need to make sure that there are no conflicts between the various departments in the FAA before everyone can sign off and say, yes, this is a good standard. Once the standards are accepted by the FAA, manufacturers can then declare compliance to the new standards and start selling new aircraft. There's a bunch of information. I have to applaud the FAA that they've made available to the public, and it is at that QR code. There's Mosaic help discussing about what's required to comply with the standard. There's information for airmen, there's information for mechanics, there's information for the sport pilot airmen, for maintainers, and a terrific FAQs page that answers just a host of questions. And these questions are all taken from the questions that the FAA has been gathering over the last 2 years. So it's real-time valid questions, and these pages are updated as needed as they get more information in. So it's an outstanding website. There's a couple of issues going on with the that has to occur once ASTM turns the standards into FAA, and that should happen this week. The FAA has to accept the standards, and if there's something in the standards that ASTM has presented that the FAA doesn't like, that could create a slowdown or a hitch. So depending on how the FAA were to address that glitch, on the backside, when the FAA accepts the standards and publishes them, if the industry doesn't like the changes that FAA made, that can be a problem as well. I guess one of the beauties of working in this environment, however, in the industry consensus standards, though, is that the methods of compliance can change. So while FAA is setting the regulation, ASTM sets the compliance to the regulation, and if FAA's acceptance has some suggestions that as an industry don't work for the industry, then we can sit down with the FAA and change the standards. It's not like a regulatory change, which can take decades, certainly years, to accomplish. In the Mosaic world and the industry consensus standards, it's very dynamic, so those can be addressed and corrected. So I hope this has been informational for you all. We can get into a lot more detail, but you're not all manufacturers and engineers, so best not to go to sleep right here in the middle of the day. Manufacturers join LAMA to influence appropriate rulemaking and create standards for our industry. Membership provides the resources for LAMA to shape policy and regulation. I want to thank you all for your attention today. These are all very complex issues. You've done great at staying awake. But those of us in the industry, we've got this disease called aviation. It's in our blood, and sometimes it just takes a lot of work to stay healthy. And by golly, together we're doing that all. Willie, thank you very much.
Thank you, Scott. And like me, he is really traveling with this around the world. The last time we were together speaking in November in China on the same topic, we will be in Oshkosh again. So this is a world issue, and we hope also that the world is uniting a little bit more again with all these troubles we have at the moment. With this, after all this dry paperwork thing called Mosaic rules, we have a nice aircraft again. Our next speaker is David Löbel, friend from Munich, where I also live at least in the area, and he has an eVTOL which is a little bit different from other things, because if you look at our topic is different use cases, and they have a use case which may occur much earlier than maybe air taxis.
Thank you, and welcome also from my side. So for me, the previous topic wasn't too dry. Actually, it's a quite important one, and like the being aviation, having aviation in the blood. Willy, thanks a lot for bringing together every year the electric aircraft community, and or not only community, but I would even say family. I'm happy to see several faces every year, but also happy to see new faces every year. So definitely there's a future of electrified aviation, and this is where I and we at ERC want to contribute to. Maybe about ERC, a couple of words, although we are communicating more openly what we are doing since, I would say beginning of last year. We are out there already since more than 5 years, and we were quite quiet about what we're doing. We followed we first wanted to deliver and then shout out, and I think what we have done is quite good. We are a very small, efficient team located in Munich, as Willy already mentioned, and we already collected previous experience many years ago with Autoflight, building up the German team. Very happy what we learned there, bringing aircraft into the air in a very quick, pragmatic way. And just more than 5 years now ago, we used the chance to take the learnings and start over again, and learn from what we have achieved, learn from what others have achieved, and try to make something better. I still believe, hope and wish for air taxis to become a reality as soon as possible. Still, I think, and for this I'm long enough in aviation, that it will still take time. It will be a stepwise approach. It will unfortunately not be disruption, and tomorrow there is the sky full of air taxis. Again, I wish for, hopefully some of you are there more optimistic and will bring thousands of aircraft into the sky as quick as possible. I want to fly in this kind of aircraft, no matter if it's a Volocopter. Michael, if it's your aircraft, I maybe have to come by and fly. I want to fly in this. eventually, what we are doing is only possible because we have Professor Schwarz, or more specifically IABG, an aerospace testing company from Munich, as our major shareholder, which in the past couple of years helped us a lot for a very good reason. It's very hard, especially with the high amount of money you need for developing this kind of aircraft, to have somebody who understands that aviation takes time and money, and it's not quick, it's not huge in the first place, although it will be huge in future. Having really somebody who believes in the future of electric aviation, this is definitely with IBG and the case with Professor Schwarz, who is into aviation aerospace since more than 50 years. And he's also a background in military, and for this I will lose some words later on. But eventually, what did Willy talk about when he introduced me, and what have we achieved in the past couple of years? So this is a slide I keep showing every month and every year, just updating it. On the very left, it's something very engineering, like having a hover frame. For an engineer, it's a piece of art, beautiful. You were able to play around with different architectures, different configurations, topologies. But honestly, selling the first one is quite hard. Even emotionally, it's some engineering where we learned a lot. And that we learned a lot, we have seen late last year when we took all the learnings from the first hover frame, put it into a real aircraft, and were able to fly our Romeo, almost 2.8 tons or 2.73 tons, we brought into the air. And honestly, the first flight, I wouldn't say it was boring, because every aircraft in this size flying, it's not boring. Every eVTOL is not boring. But eventually it worked out nicely right from the beginning. Flight controls perfectly fine. Aircraft flying in ground effect, out of ground effect, in different kind of maneuvers very reliably. And this is definitely something where at least I want to show you a couple of seconds at least how it felt. And again, in the video, it looks quite small, but it's a 16-meter aircraft, 2.7 tons, where we tested close to Munich. And I think everybody who is working into electric aviation, into eVTOLs, every time I see it, it makes me happy. But well, it's not only the case for our aircraft, but it's the case for any eVTOL that's around there. Eventually, and while the movie is still playing, I keep talking. The use cases we had in mind right from the beginning was to change how we transport things where it really matters. And eventually, right from the beginning, it was not only idea, but we had the drive for medical transport, knowing and having DRF, so big German player in medical transport, helicopter transport, HEMS operator, behind us, pushing us. They looked for a solution which might not be the perfect solution for primary transport, but at least for secondary transport, transport between hospitals, having something that is cheaper than a helicopter, but still faster than ground transport. That something that really fits in the middle, like also Michael said, having something that is cheaper for transport. Eventually, the happenings, developments of the past years, not only concerning the geopolitical situation, but also like the progress of how certification and eVTOL players in the US are progressing, knowing it's quite hard to get big amounts of money and the certification in Europe. We decided at one point, well, let's look what we have achieved in the first five and a half years, and eventually we realized we have flown every kind of aircraft unmanned, from 25 kg to almost 3 tons as a transition eVTOL, as a hovering vehicle. And since we tested already several years on military sites, actually at some point the customer sort of has to push you, and they approached us telling us, by the way, we love your aircraft. Can you just remove the pilot and fly without? Yes, we can. We did unmanned flight testing in the past 5 years. And by the way, can you make it a bit smaller because it's quite big and we want to put it on container? Yes, we can do this. And that's what we used to change our strategy in the first place. Take again the learnings of the first 5 years doing unmanned flight. And again, my target is being on the very right. I want to have crewed aircraft. I want to have aircraft where I can sit in. But still, I realized it just makes perfect sense to take the learnings and go the step in between and have an uncrewed aircraft. And this is where we currently focus on. And unfortunately, I will not reveal today. We'll just take 2 more months. You're invited to join us at ELA in Berlin when we unveil the aircraft. It will be slightly smaller, but we will use the learnings from the last 5 years. And there now actually the learnings of the 5 years pays off. We just ticked off the development in Q4 last year, and we will have the first prototype flying this year. So definitely taking the learnings, and in the end not only our learnings, but every learning in this room, all the suppliers being here. I'm very happy that these are accelerators, and I'm also very happy to hopefully prove that it's not only working under new rules in the US, but hopefully we also can work that also there are relaxed rules in Europe that makes it possible. Well, that in the end we do not all have to move to the US, but that we have cool aircraft not only built and developed, but also flown in Germany. Eventually, the last slide I love a lot. I'm using this since a couple of years, and for me it's just a shout out. It's not a competition. Well, in the end, at some point it might be, but there's so many different use cases and reasons to use the aircraft. David, not sure where you are. You will be the next one, I guess. He's not raising his hand, but he will be there in a second. I love the Volocity standing there. Perfect view here. Perfect use cases for this. Unfortunately, Lilium was not successful. Would have been a luxury transporter, and we see ourselves as the very robust, pragmatic transporter. And by the way, although I didn't show it today, we have the same slide for unmanned aircraft. So definitely there's many different applications for eVTOLs out there. And so I'm happy that close with the birds used to start today, that we're a family developing vehicles together. And yeah. Thanks from my side, and I'm happy to hear more of you and answer all the questions you might have later on.
Thank you, David. And interesting news to see. Our next speaker is an aircraft which is already around much longer time. We had the very first Volocopter, which was a gummy ball, a gymnastic ball with some motors on the arrow here. Several years ago, actually was on our booth, and then afterwards we had the first prototype, and we hope to have it flying maybe next year here at the Aero Show. But we are happy that you're back on the show, and David Bausek from Diamond Aircraft, who took over the mother company, Volocopter, will tell us where they are at the moment.
Yeah, thank you, William. Thanks that we can present today Volocopter. So Volocopter has started 2011 and has started with a multicopter. We have taken over Volocopter from Diamond Aircraft last year in March, and have restructured the product and brought in our expertise, especially in certification of aircraft and worldwide manufacturing of the aircraft at Diamond Group. We have in total, together with Volocopter, 4 headquarters, starting in Canada, then in Austria, China, and also Germany. In total, we have 6,500 aircraft on site in daily operation around the world, and certified more than 20 models, which are used in various businesses, starting from private for special missions. And with these backbones, so with a service network worldwide, we can also push Volocopter 2.0 in the next generation, so that we finish the certification of the aircraft, and also then give a professional operation to our customers outside with our global network. We have, of course, everything what is necessary, not only from Diamond as a backbone. We have also in Volocopter a production organization, design organization, production facilities. The vertical integration of Volocopter is very deep, so that means we have software development, we have power electronics development, we make the battery in-house. Not only the packaging, also the full development. That means with this deep vertical integration, we have also a very, very good cost control about the aircraft. So this brings us also in the good situation that we can offer two products, where one is on the lower end of the price tag and also enables everybody to fly an eVTOL. So our portfolio starts with an ultralight, 600 kilogram here in Europe, because the regulation is set on that with a rescue system on board. Where international, we go to 620 or more, because the platform is capable from performance-wise. So this gives you a payload for pilot plus a passenger. You can go about 60 kilometers per hour, and it will be certified by the end of the year. Then the second one, you also can see behind, so that's the City. That's under EASA SC eVTOL certification. So this will reach in the basic category, but at the EASA at the end of 2027 certification. This is in the 1025 kilogram category. If you look at the aircraft, it looks very similar than to the ultralight, but from the architecture, between 10 by the power of -7 and 10 by the power of -9 on the reliability is a difference. Also the performance of the City is on the higher end, so that means that it can be used also in special missions applications, starting from medical services, where our launch customer is the ADAC for the heli operation in Germany, up to private missions and air taxi missions. Why we have chosen this approach? Because if you look in the studies worldwide, if you look Uber or also Google Taxi, you can see that in the crowded, high-dense areas in the cities, people are going 5 to 7 kilometers and one person only, because it's for a business. It's for high-net individuals, for short range transportation. And this is also the purpose of the vehicle, and with this you can utilize it. For the more urban and more distance environments, we have also in the roadmap Polo Urban and Polo Region, which will come after the certification of the Polo City. So the Polo City, which is displayed behind you, 18 independent engines. So this brings us in the situation that we are super reliable. So one engine failure, you can continue the flight. Two engine failures, you can also continue the flight, but it decreases your range. Three engine failures, you go in a constant descent. And four engine failures, you have still a parachute. On top of that, also the vehicle can easily, because of the battery architecture, we can cover also combined cases, so that means battery failure plus engine failure. You can also continue your mission. So this makes it overall to a super reliable, safe platform. Combined with single stick control, it's super easy to fly. If you also look at the overall architecture of the vehicle, you also have to include the passive safety. So that means starting from the landing gear, which is very high in aluminum construction, so this can absorb a lot of energy. The battery is behind you. On many vehicles, the battery is below the passengers. So we have it in the back, so in case of a crash landing. So this also gives you the safety that it can't catch fire. Furthermore, we are using also energy absorbing seats, which are certified in the CS25 class. So overall this gives you a super safe aircraft. The battery compartment is physically separated from the cabin with a firewall. This also, in any case of malfunction of a battery, it only blasts to the back and it never can come into the cabin. So this overall makes the platform the safest aircraft on the market. We have 3 redundant flight control computers, which are in total, because it's in itself dual redundant, so it's in total 6 computers what we have on board, and 9 packs for the battery, which are swappable. So this also gives you a high utilization of the vehicle, because in a high-density area, if an operator wants to operate in a high frequency, utilization is the key. So the turnaround time has to be very, very short. So we can swap the battery within 5 minutes. Of course, you can fast charge. If you fast charge with water cooling, you come up to 15 minutes. So the Olo X Pro, what we have launched yesterday, so this is under full certification. So this one is in the 600 kilogram category. It will reach type certificate by the end of the year. The main difference is not in the architecture, because we are using the same components over both aircraft. This gives us a higher volume and the customer better safety, because he has really high-grade quality aviation components which are on airliner standard in the ultralight. This also is a new level of ultralight, because this is not a home-built ultralight. This is an ultralight for professional use. So we have again the engine motors. The system in case of failure is the same. You have the parachute on board. We have here in total 4 flight control computers, which is 2 boxes, but in the boxes are each 2 computers. We have 6 packs and 2 seats. So what are the use cases? So how we can utilize an ultralight eVTOL. So we see especially here in Europe enthusiastic private pilots and also flight schools who can offer, especially for pilot careers, a new type of license. Because a pilot who is on the market and has to compete with all the other pilots on the market has to think, okay, how I can make myself more valuable. So this can be only by type rating, because the basis, development or education of a pilot is all the same. So if you can achieve very easy an eVTOL powered lift class rating, that's the key for every pilot. So together with the authority, we have developed a program where you only need about 2.5 hours to reach a class rating for an eVTOL. This makes it very attractive for flight schools to bring it into their portfolio. Because if you look in the eVTOLs, if you look Joby, Archer, or other competitors on the market, we are talking about 5 to 6 or 7 million aircraft. So no flight school around the world will put an ab initio pilot for the education in a $7 million aircraft. So therefore you need a platform which is on a lower cost and can also be utilized in a flight school. Then we have air taxi, because also with an ultralight, here in Germany, the regulation is a little bit strict in that sense, but China, Saudi Arabia, Korea, or other areas around the world, they can also fly with the ultralight version. And this opens up the market to scale the volume, because you are in the price segment of an ultralight, but you still can do air taxi. Let's have a look a little bit closer in the use cases. What are the advantages? So our platform is not only electric and not only zero emissions, it's super silent because of the 18 rotors. Tip speed of each rotor, because the diameter is relatively small, creates very, very low noise. So this, especially for private owners, makes a big difference, and it's super easy to control. So think about if you're in a conventional helicopter, Robinson 22, you have pedals, it's unstable, you have to correct all the time. So those days are over. So you have single stick control. If you don't feel confident as a pilot, just leave your hands away, because the aircraft will stabilize by itself. It will hold the altitude, it will hold the direction. So it's easy to fly, and that makes also, especially for private customer, who are not flying so regularly, the platform very, very suitable. So about the education for the pilots, also especially for the private owners, because they don't want to spend much time to fly their own aircraft. So we also try to make it as simple as possible, so that the private owner doesn't have to spend much time until he gets the class rating for his own aircraft. With the 2.5 hours, which can be either done on a simulator or on the aircraft, it's only about 25 flights and you got the license. So for the air taxi, there is two things important. One is utilization, one is operating cost. So the operating cost we can keep down because of our modular architecture, because we are using the same elements for two kinds of aircraft. This gives us a big volume, this gives us a good bargaining power, and with this we can keep the aircraft cost low. So with an entry price in the ultralight segment of 490,000, we can come down, including energy costs, including lifetime components for the batteries, lifetime components engine, lifetime components rotors, also the charging infrastructure, plus the depreciation of the aircraft, and also the depreciation of the charging environment. We can come down to a price of 80 euros for a 20-kilometer trip or for a 20 minutes ride. That we keep in mind. You are in a safety level of an airliner, but can operate for 80 euros a trip. So that makes it super attractive for air taxi around the world. Therefore, we are also targeting that initially. From the architecture-wise, if you think about the ultralight certification, we are now bringing a lot of elements inside this game, because we are bringing inside electric propulsion, we are bringing inside batteries, fly-by-wire control. So all that has to be structured in new regulation, but because the multicopter is very redundant, it makes it really easy to certify it within that regulation. Charging technology, especially for certification, charging is also a topic, because with each cycle, of course, you degrade the battery. So that means your battery has to be sized that it fits the use case. So we are offering with the aircraft three types of different batteries. Starting from 100 kilo up to 138 kilo, and starting from 20 kilowatt hours up to 30 kilowatt hours. This gives the customer the opportunity to always use the battery in the optimum range, because think about your iPhone or also your electric car. If you always discharge from 90% to 10% or 100% to 5%, the battery life is not long. Also, if you always fast charge, you will degrade the battery. So you need a battery which is proper sized, that you can operate in a range of 80 to 30% in discharging, and also go from 3C charging down to 2C charging. So this extends the lifetime of the battery, here in our case, starting from 1,000 cycles up to 3,000 cycles. So this is 3 times, and this also then is the difference in the operating cost, because one time you're operating for your trip in the range of 130 euros, But if you have a proper sized battery and operating in the optimum range, you come down to 80 euros. So this is why the aircraft comes not only with the choice of battery, you also need to give the pilot the tool. So that means we have developed an own software, it's called IQ. This includes a performance battery manager. So you put in your mission, and also it gets the status of the aircraft, so the state of charge of the battery, the cycles of the battery, and then automatically calculates you what is the required energy for your trip, and delivers you with this safety because it calculates your reserve. So you never come in the region that you run out of battery. And the second is, it gives you the opportunity to operate the battery in the optimum range, which saves you on the one hand cost and extend the lifetime of the battery. Our batteries are also made that you can recycle part of the battery. So you take out the electronics at the end of the lifetime of the battery and they go in your next battery set. Only the cells itself, you have to go through cell recycling. With the next battery, each year we will increase the energy density of our battery system. So this gives you buy today an aircraft of us with a range of 30 to 40 kilometers, and each year you get 5 kilometers more. So think about that for a flight school or for an operator. The asset is there, and the asset increases every year, the value of the asset, because the range increases. So this also makes it attractive for investors. If they buy an aircraft, you don't lose if you resell the aircraft, because you just put in the next battery generation without changing anything on the aircraft. We are offering also for our customers, especially for the private segment, different kinds of avionics. For the ultralight, very traditional ones with Garmin G5 and Garmin 175, which is basically well known in the ultralight world, combined with an undeveloped screen, which basically gives you the engine instruments and then air avionics common transponder. This is the lightest solution, because if you have to stay below 600 kilo, you also need to be weight efficient. So if you can go in the 620 kilo region and want to have a more luxury one, we also offer single screen option, which basically is all in one, but because of the architecture, it's a higher rate. So normally ultralight pilots, especially here, everybody wants to have the most payload and the most performance. So therefore, we give an avionics set for the typical ultralight pilot, and we give a luxury avionics set. Safety matters, so therefore, for all cases, also if you have a stick failure, so that means if the stick is jamming or it would break, you have a backup control stick. So that means you just open your armrest, there is a second control stick below, also the circuit breakers are there, you just press a button, you use the other stick. Also for the passenger beside, so in case the pilot would be incapacitated. So the passenger has still two options. You just push on the knob on the main stick and the aircraft will descend automatically. If you push more, it will descend more. If you push less, it stops descending. So therefore you just can look down and just only press one button. If he doesn't want to do that, he can still pull the parachute. Also we give different interior options, and this with a package with the avionic options also deliver a totally new area in the ultralight class, because you can enjoy the luxury of a full-sized aircraft with the price tag and also with the licensing of an ultralight. for your attention. If you have any questions, please feel free to ask.
Okay. Actually, you already can stay on the stage, and the other speakers can back up. We have one more speaker, but we always have that you're already sitting, because then we can immediately continue with the panel discussion, and then you also can ask all your questions you have to all the speakers. So our next speaker is Ji Jin from the company Lai, which is a Ningbo light aircraft. Light aviation economy, and they are developing flight control systems for eVTOLs. So this would be quite interesting, and I hope that David comes back for the panel in 15 minutes. But you can imagine everybody's very busy here. So we'll listen to the last presentation, and then we will have Q&As and the panel. And then we have the award and the party.
Thank you, Willy. Thanks so much for giving me this opportunity to present our institute and our technology and project. Willy did a very good job to organize this event, both here and also in China. So thanks again. For the first part, I'm going to go through quite quick for the background of our institute. We're actually spin-off from the university. Which the name is called Eastern Institute Technology in Ningbo City, China, and we mainly focus on three areas. Firstly, for air safety, for the low altitude air safety to monitoring the wind and also predict the wind. The second segmented for the manufacturing of the drones, especially for the heavy lift drones. The third part is for the embodied AI for flying robot, both for our university and also this institute. Okay, since this is not an academic forum, so I'm going to go through those tech parts briefly. If you guys have any further questions, we can discuss later. So, as you may know now, in many countries there are not so much drones and also eVTOLs, but later on in the next 5 to 10 years, maybe they have a lot of eVTOLs, different types, maybe 1 million. Compared to in China, we only have like several thousand of helicopters. But imagine if we use the conventional avionics and also the combined software, it's very expensive. So we start from the very fundamental components, do the research and commercialize those for the future application in low price. So this is the hardware. So we're starting from the hardware. It's now working also for some open source flight control stacks. So this is for the software. We rewrite all the software part. And also we have a simulation framework. You guys may know if we fly a drone or drive a eVTOL, it's very expensive for failure, crash. So we have to do simulation very carefully before we take a real flight. And also, our flight computer is equipped with especially AI and also swarm protocols. This one is for the swarm part. We write our own protocol to avoid the conflict between packets. If you guys try to develop a communication protocol for many drones, it's very difficult because once all packets go through one single gateway, they will have conflict between each other. So you have to define the policy, the protocol to avoid conflicts. Okay, also very precise positioning system. Yeah, we use very accurate RTT system for many type of drones, eVTOLs, and also the ground station software. Yeah, this is we also have an open source version. if you go to the GitHub. This is commercialized one. Closed source one. And also the monitor for the packet going through all the network of the drones, many drones. Because it's really hard for a customer to inspect the commercial Wi-Fi. We don't know if we lost our connection, the video stop, and you don't know what happened inside. For drones, it's not allowed. We have to know everything to make the swarm, make the single drone very stable and safe. So we did a lot on the AI side. So it's running AI algorithm on board, not edge, to detect many type of failure, especially for the vibration, for the flight controller. And also the EMI, the interferences. We did a lot of work during the last 10 years, so we can challenge this eVTOL big drone. Yeah, this is a project for 2024. It's a very special type of eVTOL. It has designed by a modular architecture. So you can see here we have the flying module, and also we have the cabin module, and also the ground module for passengers, for firefighting, for many applications. One more thing, for the HAI also, for the acceleration, because for the drones recognize the environment for sense and avoid, we have to equip with a onboard computer, which is very fast to recognize people, trees, and the buildings and landing places by themselves, by drone itself, and also eVTOL. Maybe we don't have much time, so I just skip this video. It's a very fast drone tracing game by the computer vision. Also, this landing is based on RTK, GPS, and also the computer vision. And this is a funny video. Yeah, it's working. We use drones to track the soccer game, to give a report, to score players' performance. Also for agriculture, precision agriculture. Okay, this is not very important, so I just go through this very quickly. Yeah, we do a lot of research, and we spin off some companies. We offer open source platform for many developers to be entrepreneurs. So this is our offer. Yeah, thanks so much. Again.
Thank you, Jay. And maybe all the other speakers come back onto the stage. We luckily still have some minutes to... Yeah, just... Maybe somebody gets David Bausek to come back.
Okay.
Yeah, you have to sell aircraft to pay the expensive prices at the aero show, right? Right. So, my first question would be, from you having now, to David, having now a product out, or nearly out, which will be the X Pro. I think you have made a design challenge. So maybe you can tell our guests to see how the design will look, and when do you think the first customer aircraft in ultralight can fly in Germany?
So, thanks. So we made a design challenge, especially because to attract the private sector. We have multiple designs, and also give the designers the freedom that they can not only do delivery, they also could design the tail, they also could design aero fairings for the landing gear. So we just put this on LinkedIn and in the internet and made a challenge and said, okay, everybody who is passionate for aircraft can come and can design with us the aircraft. And the result you can see there on the screen with the improved tail sections and various designs. So what I have shown was different liveries. So the one which win the prize was one of a blue livery, which is featuring our core identity of Volocopter. So in our colors from a UK designer. And we are very happy that we can then announce him. His name is Kirk Smith. He's a passionate aviation and car designer, and he has done parallel to his work, spent many hours to bring here the designs on the road. And we are super happy that there is a community around the world who is passionate to support the aviation industry in design to deliver good products that everybody can fly.
Okay, thank you. Question to Michael Thompson. Do you tend to fly in Oshkosh this year?
Yeah, so we'll have two aircraft at Oshkosh this year. We'll have the serial number 1, which is the one you saw earlier that's been flying around both the UK and the States now for a number of hours. And we also have the second aircraft, which is our production spec, which I haven't really shown any pictures of yet. But it's a serious upgrade from serial number 1. We're taking the battery from about 50 kilowatt hours up to 80 kilowatt hours. New motors, which are IP rated sealed units with an integrated inverter on the wingtip, so ease of maintenance. It's going to, like, the fit and finish is going to be a lot nicer, similar to what Volocopter have done. The interior specs are going to be much nicer than what the serial number 1, which really was just a prototype. So yeah, Oshkosh is going to be cool to show that.
Okay. I have a question to Scott. You had talks, I heard here also with EASA. Yesterday we had David Solar from EASA, from the Innovations Department. Do you think, because that's important for us, you now have the nice mosaic rules, and we don't want to look jealous over the ocean again and say, okay, why don't we have this? Why can we only fly with much less kilograms and less opportunities? Although over the last years we could fly electric ultralight or a volocopter, which we could not fly in light sport. So it's going maybe back and forward. So do you think from the talk on the show there will be LSA mosaic or a mosaic light change to LSA also in Europe?
That's a terrific question, and I wish I could influence that more. In the discussions I've had with the EASA, I believe they want to. And what I hear from manufacturers here in Europe, that change is slow. Certainly, that is shown with the great speed that FAA has put Mosaic together and implemented that, which was one of the fastest rules that the FAA has ever done. And so that makes everything else look slow when they go very, very fast. I have seen a whole new collaboration between the FAA and EASA, so I'm hoping that there are things that FAA would like in terms of getting Mosaic, getting European aircraft into the United States, and there are things that EASA would like from FAA. And so if those desires of each entity mature and come to fruition, then that becomes a win-win situation, so that it will, EASA will be happy to work more quickly and with incentives from FAA, and FAA, certainly there are some things that EASA can provide to FAA to help the aircraft from Europe get into the United States quicker. So there's incentives on both sides to improve the regulatory environment and the speed that the product comes to market.
Okay, thank you. David, the other David, David Loeber from ERC. I heard that you say, okay, you're now having a smaller aircraft as well, which you will show in Berlin. How small? How small will you go? Will we also have a Mosaic ERC, or are you not looking?
Well, it depends if we move to the US or if EASA is moving quickly. No, but in the end, we're talking about like 1 to 1.5 tons still takeoff mass. Eventually payload class 250 kg.
Okay. Another question to David Bausek, to Volocopter. Do you think that because the Volocopter were flying based on the ultralight certification also in the United States, like in Oshkosh, I remember a few years ago, which was still with the ultralight microlight association certification number. When are you going to bring it to the States again? You're going to bring it to the States again and try to fly Mosaic class?
Of course we will do. It's just a matter of time. Yeah. So we do step by step. So we will see who wants to go concurrent with us on the German ultralight certification. So we are reaching out to other authorities within Europe who are also passionate and want to be the first ones. So we will explore that first. Once the TC is granted, we will also go over the ocean, of course, and explore then with FAA Mosaic. Yeah.
Okay. And on the Medivac side, will this also fly? This will be based on the Volocity, so on the certified aircraft, not on the microlight. Or will you do some tries, maybe already with the microlight, because this will be available if one's passed certification?
So depending on the customer, here in Germany, because of the performance class, we are basing this on the Volocity. However, international, there is a lot of air rescue also pretty interested, starting from blood transportation over organ transportation. So all these services, what can be done more efficient, where the infrastructure of the hospital is already there. So there we can also fly. It's then not set as ultralight, because if we certify in China, it goes the regular way. It's still in the class from the weight as a German ultralight, but it's not certified as an ultralight. Also here in Europe at one point, of course, 620 could also go the other way. If this makes sense, we have to see, but international, we will utilize also the ultralight platform on medevac missions.
Okay, so looking forward into the future, as we have 3 manufacturers here, next year at Aero, because we want to have a nice flying again, we want to have eVTOLs flying. So,
if I have an aircraft in the UK, I will display it. But the first base we're going to certify is the States, so it wouldn't be a good use of my resources to have it flying here. But if we can see some traction, if there's movement, and I feel like there's enough customers here in Europe, then we could display it. But it's a tricky one to justify the cost and bringing it somewhere.
So you say display, but then to see you flying is very unlikely next year.
Potentially unlikely, yes. But I'd love to do it. But yeah.
Okay.
Billy, you will definitely see us flying, if at Aero or somewhere else. Let's see.
Okay. So I have to work on you to have you at Aero.
So just an interesting nuance for the multicopters. You have two things in regulation. You've got the regulatory side, which is what Mosaic is, and then you've got the compliance side, which is the standards. So the regulation states the stall speeds in order to be a light sport aircraft. But on the standard side, some of these aircraft don't stall. So what do you do with that? So we changed the language, and language is how we communicate, so that now the standards are addressing a minimum safe flight speed. So that helps the multi-copter side because there are requirements that are required at stall, and if your minimum safe flying speed is zero, then that just really reduces the burden for the multi-copter side. It's just a little nuance, but from an operating and a compliance standpoint, makes things much easier to go, and a nod to the embracing of new technology, which I'm very excited about. There's not a plane there's not a flying craft up here that I wouldn't hop in a second. And you all need to be paying attention to that, because I'm going to take you up on it.
David, you also say you're going to fly next year? Of course we will. So that's pretty easy, yeah. So we plan a sandbox model this year. So a sandbox is restricted airspace. In October or September this year, what we want to establish in Germany, so that we can also bring our customers inside the aircraft. They can test the aircraft, they can fly with us, and then next year, Aero is a must.
Okay, very good to hear. So I think with this, it's a nice final word for an eVTOL discussion. So next year we finally will have eVTOLs flying here. I also have the promise that if Pivotal gets further with the German regulators, they want to fly here. So we've got already two. So maybe we really can see some change in the air here in Germany. And with this, thank you very much for being on this panel. And stay.
You can change the next part of the price slide.
Okay. And this is what's coming up next in half an hour. So the aviation award, maybe we get a little bit closer together to make it easier for the people to get something.
See you later at the party, I hope.